Hello everyone, welcome to this demo that will be about Thoth's Build Watcher. My name is Fridolin and let me guide you through this presentation. I will talk about the component that is called Build Watcher, and this component can automatically watch for application builds that are happening inside an OpenShift cluster and can automatically submit relevant information to Thoth backend. The main purpose of this component is to automatically aggregate so-called observations to Thoth knowledge base. We understand behind observations something that is that are information about either successful or failed application builds that are happening inside cluster. We use this information to aggregate data and to improve our recommendations that are produced by Thoth's recommendation engine. So in other words, we want to extend our database of known issues that are happening during application assembling, during installation of libraries, so that we can implement new advisor units. Advisor is our recommendation engine, so basically to improve our recommendations. Thoth's Build Watcher is a component that is deployed using deployment config. It is living inside an OpenShift cluster, inside a namespace, and it monitors events that are happening inside OpenShift namespace. And if it finds out there is a build, either successful or unsuccessful, it extracts the following three information. That is the base container image that was used during the build, the resulting or output container image that was produced during the build, if the build was successful, but also build blocks that were produced during the application assembling. So the text printed to standard error or standard output. These information are automatically sent to Thoth backend, and which information are sent, that's configurable, so you can configure Build Watcher to send any of these three or any combination of the three stated. On the backend side, these information are automatically analyzed and the relevant information for Thoth automatically extracted and stored on Ceph. That is our object storage. If we take a look at the architecture, you can see on the left-hand side an OpenShift application that is basically client application or user's application, user of Thoth. And here you can see that Build Watcher was deployed into the namespace, and there were two builds called Build 1 and Build 2. Build Watcher automatically detects that these two builds happened inside the cluster and extract relevant information. As Build 1 was successful, the extracted information are base image, output image or the resulting container image, and build block produced during application assembling. The second build was not successful, so there was no output container image or the resulting container image produced, and in that case, Build Watcher submits only the base image and build blocks that state the error that was encountered during the build process. On the right-hand side, you can see Thoth application. Thoth is OpenShift native application, so it runs inside OpenShift, and one of the components is Thoth's user API that exposes endpoints which accept this information that is automatically submitted by Build Watcher. Once Thoth user API accepts information on its endpoints, there are submitted to analysis. Build analysis 1, which corresponds to build 1, and build analysis 2, that corresponds to build 2. The results of these two analyses are stored on Ceph for further processing and further analysis. Here you can see the client side. So we already know that Build Watcher is a bot that is monitoring cluster events, extracts relevant information, and there is one important intermediate step, and that is when builds are using internal OpenShift registry. In that case, Build Watcher automatically pushes resulting container images to a remote container registry based on the configuration supplied, and it performs this operation so that container images are available to Thoth for analysis. If we take a look at scenario that is supporting this idea, let's say that build 1 is configured to, or the build 1 succeeds, and build is configured to automatically push the resulting container image inside to the OpenShift's container registry. In that case, OpenShift pushes the resulting artifact, that is the container image, to OpenShift container registry, and upon build success, Build Watcher detects this fact and sends or pulls the container image from the OpenShift's internal container registry and pushes it to a remote container registry that can be, for example, Quay. Then the request to Thoth backend is adjusted so that Thoth can analyze container image that was pushed to the remote container registry. If we take a look at the server-side architecture, user API upon request schedules or sends a message to Kafka, and once we have available resources inside a cluster, there is scheduled build analysis workflow that is using Argo workflows, and tasks that are run within this build analysis store results to Ceph. We reuse this architecture from other Thoth components, and this architecture proved to be scalable. So we were able to run 100,000 of components, different components, but they were using the same architecture. These components were Thoth solvers that analyzed 100,000 Python packages. Once the data are available on Ceph, we can take a look at something that I called constant improvement loop. So once data are available on Ceph, we do data exploration. These data are prepared. There is extracted information, and they are in form of JSON files, so they are machine readable, and they can be easily explored. So in that case, data scientists and software engineers can explore this data and derive some information out of it. This can eventually be some advisor unit, so a new recommendation for users. And that means that we are improving the recommendation engine, we are providing better recommendations, and that means that resolved application stacks by Thoth are better. If there is some issue spotted, again, we monitor builds that are happening inside the cluster, and these builds are automatically monitored, and upon success or failure, we run these build analyses that I stated before, so that we have prepared data on Ceph, which are again ready to be explored and ready for additional data mining. Thoth provides adapters that are available in Thoth storages module, and these adapters are a comfortable way how to explore the data set that is available on Ceph. These adapters can be used within Jupyter notebooks, so data scientists have really comfortable and easy to explore interface to data. Software engineers and data scientists can also benefit from another component, that is AMON. So if there's something wrong spotted on data that are present Ceph, then there can be run AMON inspections to verify found issues or justify found issues, and additionally explore any other issues that can arrive with users' software stacks, and this can eventually again produce better recommendations, so we implement new advisor units. On the backend, during build analysis, we run two analyzers. The first one is called package extract, and it is responsible for extracting packages that are installed and available inside container images, meaning RPM packages or Python packages that are installed inside these container images. We run this analyzer on the base container image as well as on the output container image if they are provided. The other analyzer is build log parser, and it understands build logs that are produced during the application build or application assembling. It can parse all the relevant information, extract this relevant information, and create a JSON output. For this purpose, we use MicroPipenv. This is a tool that we developed for installing applications or installing dependencies of applications. MicroPipenv has nicely structured logs, and you can spot issues nicely in these logs. So these are unified logs and optimized for users, so they can easily spot issues. But MicroPipenv can also be used, or logs produced by MicroPipenv can be also used in build log parser. In that case, build log parser can detect entries in the output and create a JSON report out of it. If you do not use MicroPipenv yet, you can enable it in all container images that are Python source to image container images. They need to be Python 3 because MicroPipenv is available only for Python 3. And you can benefit from MicroPipenv in Red Hat Enterprise Linux container images, CentOS container images, UBI container images, as well as Fedora container images that are Python S2I based container images. Here is a screenshot of build analysis workflow. So here you can see a workflow that has some ID. The screenshot was taken in Argo UI. And you can see one task that is a parse build log that is basically running build log parser. The other task is extract packages. That means extracting packages that are available inside container image. And these tasks are run for the output container image or the resulting container image, as well as for the base container image. Extracted information about packages is subsequently synced into Thoth's knowledge base using graph sync. That is another task run within the workflow. If you want to use Build Watcher and that way help us to improve our recommendations, you can follow instructions that are available inside README file, available in ThothStation Build Watcher repository on GitHub. Don't forget to enable MicroPipenv if you haven't done so. If you are using Thoth S2I container images that are S2I container images that are produced by Thoth team, MicroPipenv is enabled by default. So you don't need to export this environment variable, but if you do export for the sake of compatibility, there's no issue with that. And if in case of any issues either with setting up Build Watcher, or if you spot any bugs, issues in Build Watcher, do not hesitate to contact Thoth team for further assistance and help. This way, I would like to thank you for your attention and see you next time.